Welcome to the past HSC exam question videos. In this exam question we cover the 2010 exam question number 22, and this one is worth 3 marks plus 3, so it's going to be worth 6 marks. And I'll read the question as an A part, which is worth 3 marks, and the B part down here, which is also worth 3 marks. So I'll read the actual question. It says the following data were recorded about the effectiveness of anti-malaria drugs for treating malaria. So let's talk about how effective it is. We've got the years, the different types of drugs, and the percentage of effectiveness. And the question says, A, graph the data on the grid, and B, use the data to explain the impact of human biodiversity. Both of these are worth 3 marks. So when you're ready, pause the video and attempt the question. Once you've attempted the question, press play. I'll go over the actual question itself, both A and B, and how to answer them to get full marks. And I'll also give you a sample answer as well. So yeah, when you're ready, pause the video and attempt the question. Welcome back. Alright, so for the actual first part, the graphing part, it's actually, you can always expect a graphing question in every single HSC exam. There'll always be one, and it's easy points to get, because to get 3 out of 3, all you need to do is correctly plot the data. So you'll have to grab this data and correctly plot it. You need to label the axes, and you need to provide the lines or curves of best fit. So you need to connect those dots properly, and that'll be 3 marks out of 3. And if you do any of those incorrectly, you get less. But to show you how that would look like, again, this is not perfect because I couldn't fit up my whole graph on there. But the idea would be simple: that you have what you measure goes on your y-axis. So you measure the effectiveness, and the years. Sorry, I'm just really tired today. Or tired at the moment. The years, so the data in terms of years goes on the other side. So you've got effectiveness up here, and you've got the arrow pointing up, and you've got the year on the other side. Then what you also have, you have legends, right? That show you that the blue is meant to be the metal for quinine, and the red is meant to be the quinine. And then what you do is you plot, right? So you've got 1 mark for the correct actual labeling, so of both sides. You get 1 mark for correctly getting those dots and putting them where they're meant to be, right? The plotting of the dots. And then you get another mark for actually connecting them correctly, right? So that's it. You get 3 marks out of 3 for doing that, and it should look something similar to like this in terms of your graph itself. And then the B part was use these data to explain the impact of the human's processes on biodiversity. So to get 3 out of 3 for this question, you should correctly identify the human processes, correctly link the response to data, and correctly link the use of drugs to change in biodiversity. So in this case, what that means is we need to talk about how humans can cause evolution, more or less. So evolution of, in this case, of the protozoa in question, the malaria causing protozoa. And so evolution is caused because they become resistant to the drugs, right? And because they become resistant to drugs, that means that some of the new produced antibiotic resistant protozoa will be different to the old ones, which means we've increased biodiversity, we've changed nature a bit, we've added more variety, because we have these really new ones which are really resistant. So basically, we have to talk about how what we do is making the actual animals, or in this case bacteria or protozoa, more diverse, and we need to link that to data as well to get 3 marks out of 3. So what I wrote is humans can directly influence the evolution of species by changing the selective pressures that these species are facing. Selective pressure just means whenever these animals have to survive to be able to reproduce, right? So selective pressures are usually the things that are most serious to them, the most dangerous to them. And this occurred with the pathogens that cause malaria, as new drugs are introduced to eradicate the protozoa. So for these malaria-causing protozoa, basically these drugs were the selective pressure. Right? The ones who were resistant would survive, the ones who would not be resistant would die. So all I just said here is that humans have that ability to cause evolution in living things. Then I said the widespread use of drugs is causing the weakly resistant members of a species to die off, whilst the more resistant will survive. This leads to drug-resistant pathogens that develop from this overuse. It's not mentioned antibiotic resistant because in this case we're not talking about bacteria. Remember, we're talking about protozoa, and protozoa are not bacteria and they will not be harmed by antibiotics, which is why the actual question just says anti-malarial drugs, not antibiotics, right? So, but same idea. You overuse them, they become resistant, and then that's a problem for us. But the last part was about the biodiversity, because we have to link it to biodiversity, and we have to also talk about the actual data here as well to get full marks. So the biodiversity of the Plasmodium pathogen, and that was just the pathogen that causes malaria, thereby increases, as these pathogens have evolved genes that helped reduce the effectiveness of malaria drugs, such as meliquinine, as can be seen on the graph. Right, so we've linked it to the actual data on the graph. We've said that the biodiversity increases because these pathogens now have these new genes, so we have more variation. And we've also said that this is due to human influence, because the humans have made these new drugs, and these new drugs is what these protozoa are adapting to. Right? That's basically to get you full marks for that. And the question comes, in this case, from this dot point: gather and process information to trace historical development of our understanding of the cause and prevention of malaria. So we know what is causing malaria, this protozoa, and we know how to try to prevent it, but these malaria drugs are becoming more and more less effective at prevention because they're becoming weaker. But hopefully that was useful.